Greetings. Welcome to week 3 of CS150 scripting. Uh, we're going to be concentrating today on the creation of functions, creating a file IO, and a modular code. So far, let's kind of review what we learned. We've learned how to run commandlets, how to store data in variables, how to filter using the pipeline, and how to use conditionals and loops. Now we're going to take a big jump here today. We're going to start talking about scripts that actually really work and are really useful. So, this week we're going to move from writing scripts scripts that work, scripts that are structured, they're reusable, they're maintainable. All those good buzzwords that we write a program, we want our code to basically be having these characteristics. We will cover writing functions, using parameter blocks concept, reading and writing files, and creating reusable modules. Key thing, reusable modules, you're going to see that kind of perpetuate all throughout the class. We also always want, if possible, that what we're writing is reusable so that we don't have to rewrite the code. If you have something that someone else can use, or when you get out into the real world, okay, my term is that you're going to be writing code that you're going to write, and if someone else hasn't written it, you're going to use it. But if you are the first one to write it, your code you write, you want to be able to pass it on to someone else. So later on, when they use it in their system, hey, you don't have to reinvent the wheel. Okay. So that's what we're talking about when we're talking about creating reusable modules. And this is where scripting becomes engineering. Okay. Before, we're just looking at scripting as being a kind of new programming language. Now we're going to be jumping into and how we actually re-engineer systems. Structure. One of the things that we would definitely be delving into is trying to create structure. And so if you look at this, the reasons like that, if you have a program that went from 20 lines of code to 200 lines of code to 800 lines of code, if you did not have it structured, okay, in modular form or something that's easy to follow, it would be a disaster trying to change it and have to document it. So without structure, it becomes hard to read, it's hard to test, it's hard to modify, it's hard to reuse. Professional scripts are modular. Modular means that we're limiting the amount of or number of lines or activities that are happening in a given program or script. That means we have smaller components, clean inputs, clean outputs, reusable logic. And so today you're going to learn how to do that. Writing functions. A function is a group of reusable block of code. Okay, so here's the classic example. Simple example. We have a basic structure is a function. We say function. In this case, we're getting greeting, and we're writing host hello. Okay, writing host means we're going to write it out to the terminal, which you know by now. So write host hello. And to run it, all we have to do is say get greeting. We've already created the function. All we do is give it the name of the function, and then that particular function will be executed. Okay, so if we were going to build something practical, here's an example. Here we're function is called getting running services. And what we're doing, we're going to get service, and as you know, getting a service gives us all the services that are currently available to be run, that are runnable, okay, in the system. So here we're going to get all the services, okay, where the object, okay, where in this particular case is the service, it has a status of running. And remember, $dash means this current object. So as I read services, object services, for the given object I'm on, I'm going to check to see if it's running. Okay. So that's this particular function. We're just going to get a service that are running. And we're going to call it get running services. Here, we've encapsulated logic, we've reduced duplication, We've improved readability. This function can be used by other systems or other individuals who want to do the same thing. A classic example may be that any system generated here at Carolina University will have a greeting that says, "Hey, welcome to Carolina University. Glad you're here. Hope we can help you in any way we can." Okay. And say any system we have there, we wanted to use, we wanted to make that statement. We can create a function, similar to what we're doing here. Okay. Back up here. Yeah, right here. To say, okay, here's our Carolina University greeting. Okay, so we can put that in. Everyone could use the same function, and that would just be a piece of a script that's basically available to everyone to run. And everyone they don't have to redo it, don't have to reinvent the wheel. Same thing here. Anytime someone wants to get running services, they'll be able to use this particular function that's already been created just by calling get running services. Okay, here we're making a little modification. We're still running the services, but what we're doing here is this is a collection. So we're getting a collection of services that basically meet the criteria of a status equal to running. And here, once we're finished, we return the service. So we're getting services, we found, identify those that are running, and we're going to return those services to be used by the next step in the process. Important concept. Functions should return objects and not display text. You should avoid overusing write host. Write host just says, I got something, I'm going to take the text, I'm going to write it to the terminal. Okay. That is not necessarily good. I mean, if you want to, if that was your goal, but just think about it. Your scripts are going to be many times run offline where nobody's going to be looking at them unless there's an error. Okay, so using write host doesn't really matter because you're assuming that someone is monitoring to see the results of what you're writing. So here we're basically, we want to return objects and returning data when possible, and not just to output something out to the terminal. We do that now just to get used to, the writing and see what is happening, see how it processes. But in reality, what we want to do is basically capture objects and return those objects for processing. Okay, parameter blocks. Functions become powerful when they accept input. Okay, so this is our first look at where we're actually accepting something, into the function, and based on that, we're using that information. So in this particular case, we have a function, get processes above its CPU, param, and that dollar threshold says this is how I'm accepting the input of what is that threshold that I want to be able to capture for those items that are processed above that CPU. So that CPU threshold is basically an input here from a parameter. Once we've accepted it, then we get processed. We look at every object. We look at the CPU field for that given object, and we want to see if it's greater than the threshold that was accepted as input. So when we call it, we say get process above CPU dash CPU threshold 100. This is where we're passing that parameter data into the function. Breaking this down, parameter block defines the input, int defines the type, dollar threshold becomes the usable inside the function. So basically looking here. Notice in this particular case, our input is integer. And as described here, integer defines the type. Okay, why is this important? Because hard coding values is a bad practice. Okay, hard coding a value has always been a bad practice because anytime you want it to change something, you have to go in and actually change the code. Okay, so this is basically to get around that. This is bad for the given object that I'm on, saying that we want to see if the CPU is greater than 100. Better that we do the same thing, but we have a variable that is inputted where we get the threshold. Anytime we can do that without hard coding, that's what we would like to do. So here, now your function adapts. Professional scripts are flexible. You always want to look at that. Whenever you're writing scripts, make it as flexible as possible to be used by others than yourself. Okay, so here, talking about external data, we have serverlog.txt. Here we have example contents. We have info, system started, warning, this usage at 85%, error, failed. Okay, all of these are examples of text. So here, excuse me, 1 second. Okay. Okay, so had a cough. Sorry about that. Okay, so we'd like to keep this rather live too. So maybe little bit of live action for you. Okay, so here we're talking about getting external data. In this case, we have a server log.txt file, and in that file example, what could be in there is info, system started, warning message, error messages, fixed login attempt, failed login attempt, or unauthorized access. So now reading it, here's how we're getting content from the external file from the server log.txt. We're storing it into a variable called log here. And here, basically, what we're doing is we're looking for errors. So we're looking at the log where the given object that we just read has a error or has contained in it anything that like error. And notice there's an asterisk here. This asterisk says, give me anything that has error after it. Okay. And this particular asterisk says, give me anything that has error before it. So we're looking for the keyword error out of the log that we basically got from an external file. And here we're going to keep a count. So errors.count. Okay, this is the basic log analysis. So I've gone through here and basically said how many error conditions did I have. Okay, and that's basically personified here. So we're doing analysis of external information, okay, and taking that information to basically provide an additional analysis of what we're trying to accomplish. Okay, writing data out to a file. In this particular example, we have errors out file dot dash error report text. So here's where we're writing errors to the report text file. Formatted total errors. Okay, we want to print out. And basically, we're taking those total errors and we're outputting that. We're passing through. There's our pipeline, item, okay, or syntax. And so we're looking at total errors. We're taking that error count. We're passing it to our out file, and we will be putting it on the error report.txt. Okay, default behavior overwrites the file. In this particular case, as I'm writing, here is the saying that what I write to the file is going to overwrite whatever's there. Okay, but you can append using dash append. So if I use dash append, then what I'm going to be writing to that error report.txt file is going to be added to rather than overwriting it. Okay, so an example, audit complete. Okay, at get date. Okay, output file, we're going to put that on the report. We say append. So here we're just accumulating information. Okay, then we're looking at audit completed at a given date, and we're just writing that information for each date. Okay, the errors that happened, that occurred using this particular criteria. So here, writing out a file based on information that we received externally. So we're writing that information out to another file. Okay, creating a module. Okay, now we move into module design. A module allows you to store reusable functions. Okay, so we create a file, log tools.psm1. Okay, inside we have a function get error count. We input here, we're actually inputting a path, okay, a string path, a path name. And what we're doing is we're taking that information. Grace, you're going to be creating it, putting it in a variable called log. So we're going to get content based on where it is in this path. Okay, and then we're going to return log where the object has errors in it. Before, remember, we took anything that, excuse me, we took anything that had an error and we put it in the error report.txt. Okay. Here, what we're doing is we're pointing to where that file is located, get the contact path, and then we're basically running through the file and we're looking at, okay, the number of errors that are in that text file, and then we're getting a count. So every time we hit an error, we're going to count it by reading the text file, the log file, based on that path. Okay. Save it, import the module. Okay, we import module.log tools.psm. To use it, we call get error count the path, and the path is the server.txt name. Okay, that is what we're looking for. That's the file that we're going to be looking to process. Okay, why use modules? You can reuse code, you can share across scripts, you can maintain centralized logic, you can avoid duplication. This is professional practice. Reuse is the magic word in developing not only scripts, but also developing programs. But in this case, we're talking scripts. Okay, putting it all together, now we combine everything. Here, we're basically inputting a parameter, which is a path here to the particular file that we want to process, the log file. Here we have a function get error count, where we're taking that path, which designates where our particular audit file or text file, error file is. Here, we're basically giving it a name. Here, we're scanning through that particular path name or file, and we're looking for errors. We're getting a count. Okay, we're taking error count here. Okay, and we're putting it on the log path. Well, here we're designating where we want to put it. And we say if error count is greater than zeros, we say error detected, error count, and we write this information to the report text. Okay, so again, what text file we're looking for, what are we looking for in the text file, okay, in the log file. Once we get that information, we write that out to a report.txt. Else we say, hey, we didn't find any errors. No errors detected. And we write that particular string out to the report file that says there were no errors. So this is a way of looking at things that if you had this particular script run at night and then you come in the morning, you want to know, well, what kind of errors did I have? Okay. This would be a script that you could use to run that basically keeps track of the errors. And either you're going to see a list of errors, okay, by looking at that report.txt file, okay, or what you're going to be looking at is no errors detected based on that script running the previous night. Okay, so this script just kind of we walking through it, accepts input, uses a function, reads a file, makes decisions, and writes a file out. Okay, so in your homework or your project, you say, well, this is what I need to do. I need to read something from a text file, do something, and write the results out. We'll come back here and see how this is done and basically use this particular criteria to write our own. Hey, nothing to say that you can actually copy this and make changes to it that basically specifically outlines what you are looking to do. Okay. Again, reuse code. You don't have to start from scratch. You don't have to be an expert in knowing the exact syntax. All you need here is an example of showing you how it's done, and basically you can just plug in what you need to change. Okay, so common mistakes you need to look at for is you forget to you forget to import the module. You overuse write host. You know, just as you're not really getting objects, you're basically writing stuff out, expecting someone to read it. Okay, hard code file paths, and we don't want to. Basically, when we're talking about in this particular case, the name of the input and output files, we don't want to hard code that. We want to make that an input parameter. Forget parameter types. Okay, mixed display, output, return values. Okay, all of these you need to look out for. Remember, scripts should produce usable data, not just pretty text. Okay, that is really very important, that what you want your scripts to do is be actually usable. And some of the things that you'll be doing with your homework and a project kind of sets you up for that. So in closing, you now know how to structure code, to reuse logic, to accept input, to process files and create modules. So accept input, process files means I can reading in files and writing out files. Okay, we've basically covered both of those. So this is what separates basic scripting with professional scripting. Turning repetitive code into functions, using parameters instead of hard coding, reading and writing simple files, and creating at least one module. Okay, you want to try to modularize everything that you can in order to make it easier to read. Okay, so that's it for week 3 on our video lecture. This will be available in your class shell. So you'll be reading that. It should be very visible for you, and we'll basically take this and we'll have our in-class lecture for those who are in class or face-to-face. We'll have this ready to fall in through Tuesday, under the assumption that you have read this before Tuesday. Okay, but read it anytime. Some of the information presented here is going to be the same as what's presented in our lecture, but anytime you can read this, because it definitely will help you in your homework and your project that you'll be working on each week. Okay, everyone. Thank you, and we'll see you next week for week 4. Have a good one.